Good morning, everyone. My name is Vaishak Yashodharan. I'm going to present the work entitled The Preliminary Analysis of Processes to Produce Biodegradable Fishing Nets, collectively prepared by the people of Technology for Circular Economy and Natural Security Research Group of the Department of Chemical Engineering from University of Santiago de Compostela. This research focuses on the search of information on the synthesis of polyhydroxybutyrate for manufacturing biodegradable fishing nets from waste of tropical fruit pineapple. By using process simulation, the polyhydroxybutyrate biosynthesis from pineapple waste will open new pathways in research for scaling up and low-cost production methods. The objective of this work is to study and compare proposals of potential production processes of polyhydroxybutyrate from tropical fruits using process simulation. In addition, the feasibility of using cotton as a raw material for both fish aggregating device and fishing nets is investigated in the marine environment, considering the material properties, and is compared with polyhydroxybutyrate. For the study, a bibliographic review was carried out using the Web of Science platform. Based on the objective of the study, the combination of keywords polyhydroxybutyrate production, biomass, process simulation, and pineapple was used. From the literature review, it was found that there are almost more than 2,000 literatures related to polyhydroxybutyrate production, more than 500 literatures related to production of PHP from biomass. Process simulation studies on PHP production were only a few. Finally, it could be found that PHP production from pineapple were only 3. There were no papers related to process simulation of biosynthesis of PHP from pineapple waste. Based on the literature review, it was found that there were no studies till now conducted on process simulation of biosynthesis of polyhydroxybutyrate from pineapple waste. So this study will be the first initial study conducted on process simulation of production of polyhydroxybutyrate from pineapple waste. Process modeling consisted of pretreatment technologies which are usually employed to break down the complexity of cell networks of lignin, cellulose, and hemicellulose for enhancing the accessibility of enzymes to promote hydrolysis. Polyhydroxybutyrate is a bio-based polymer produced from glucose and starch by metabolizing bacteria. From literature, it was found that Cupriavides necator was used for PHP production. Pineapple peel hydrolysate showed highest yield of PHP substrate produced by 1.5% volume by volume sulfuric acid hydrolysis. Therefore, PPH is selected for this study. The PHP substrate concentration was set as 20 gram per liter. There was no nitrogen content found to be in the substrate taken for study. Microorganism Cupriavides necator was defined as a solid component, while enzymes were defined as non-conventional compound for simulation, and UNIFAC model was applied for thermodynamic simulation. While modeling in Aspen Plus for pretreatment process using carbonic acid, stoichiometric reactor was selected as a unit operation block. The molecular structure of PHP was user-defined. First, it was defined as a conventional component. Then the user-defined platform was used to draw the structure of PHP. Then with the help of user-defined component wizard, the data of component is retrieved, pure properties of the component from NIST TDE platform, after which the sensitivity analysis was carried out. Bioprocessing of polyhydroxybutyrate from pineapple fruit waste was designed and simulated using Aspen Plus software for the first time as a preliminary study for using it as a raw material for fishing net and fish aggregating device production. Carbon sources such as fruit waste can be directly used as a source of PHP without excessive pre-treatment. Fruit waste are cheap sources which creates both economic and environmental benefits when utilized to generate biodegradable materials. The results obtained from Aspen Plus simulation and sensitivity will be useful in scaling up the production and new pathways for research. Extensive studies have to be made to enhance the physical properties of PHP. Thus, developing more sustainable pathways for production of PHP from fruit residues, the raw material use is maximized and waste is reduced. Even though PHP are suitable for saline environments, its feasibility to be used as fish aggregating device should be further investigated. Natural fiber cotton was found to be suitable candidate for biofat since it is easily available at very low cost. Thank you for your kind attention.